Hello again, and welcome to another tutorial on how to use the latest DT6 software. Another feature that's been added to the latest version of DT6 is what's called live mode. You'll see it down here. And what live mode lets you do is it lets you see the data live as it's coming in. So whereas in the normal acquire, which is what's always been there, you would set a certain amount of time and then hit acquire, and it would get that amount of data, and then you could go to the analysis portion and look at it. The live mode feature has the added benefit of being able to watch the data coming in. So it's useful when you don't really know anything about how the certain machine works and you'd like to just see what's currently happening to it. And the other benefit is that once you capture that data, it'll come back in here and turn these lights on green as if you had just run the acquire button for a certain amount of time, and then you can go into the analysis and look at it as that. So we're going to go ahead and press the live mode button. And when we press it, we'll be brought into this window. And by default, it'll show you the FFT and the other FFT. So you can go ahead and zoom these guys out. And then we'll go ahead and look at the waveform, and we can see what's currently coming in. And if I go ahead and turn on my motor that I have plugged in right now, we can see that here's our data coming in. So we can go ahead and zoom out on it. And as the motor turns on, we can see this data coming in. Then we can go ahead and go to the FFT, and we can get a live view of what the FFT looks like for every set of data. In the top right corner, we have this option called refresh rate, which basically determines the amount of seconds you'll see on the screen between here to here before the data refreshes and goes back to zero. Keep in mind, though, that all this data from previous trials isn't lost. It's all saved into one big portion, but this just lets it so the computer can keep up with it. And so that you don't have to look at all the data, you only look at the last like 6 seconds or something, but you can change this to whatever you want. We would recommend somewhere within the 0 to 10 second range, just because any more than that, you'll start to see a little bit of a lag on the graph here. But for our most purposes, we found 6 seconds is a pretty good number. So then you can go ahead here and you can press the filter button, and these values are in hertz, and so if we want to filter the signal between 10 hertz and 150 hertz, the current motor I'm using is 30 hertz. So if we go ahead and filter this, we can see kind of what the signal would look like when it's been filtered, and then we can go to the FFT and we can actually see the differences here. So if we take away the filter, we can see all the extra stuff beyond, the 150, which is like there. But if we turn it on, it starts to drop off. The filter isn't a perfect filter, like all filters. So if you were to put in 150, everything past 150 isn't necessarily going to be zero. You can see here there's a peak at like 210, which if we turn off the filter, it's all the way up here. But if we turn on the filter, it gets brought down. All the values outside of this range get brought down, but they don't necessarily get brought down to zero. That's just something to keep in mind. Another thing you can see is we can get a live frequency of what the current sensors are measuring at. All the sensors have about it's about a 1% error or so on the 3200s. So in this guy, the sensor's supposed to be at 3200 and it's at 3252, which is better than what the sensor is actually advertised to, so that doesn't matter. And this guy is, within 5 hertz of the 3200 advertised hertz amount, and instead we can see that 5 hertz is going to be within that 1% amount that it could be off, so we're good there. And once we've satisfied that this is the data we want, we just hit the stop button and it'll save all that data, and then we're brought up with this window that lets us clip it into a certain portion. So I'm going to go ahead and turn off my motor now, and we can see here that this region right here is when I had my motor off, so I don't really want to include that because it's going to throw my results off. So we'll go ahead and bring this cursor over, which is going to show us when the start is, and then you can see as I bring the other cursor over, this FFT on the bottom will show us the FFT of the region between this cursor and this one. So, and we can see here that, we have 25 seconds to just about 85 seconds. So right now, that amount of time is like 60 seconds worth, which is a pretty decent amount of time. And with the acquire, you'd have to run it for 60 seconds without knowing what's happening. But in the live mode, you have the added benefit of being able to watch it as it's coming in. And then we can go to the cut portion tab, and that just shows us what this data is going to look like if it were to get cut here. So this would show us what the waveforms that would be outputted for would be. And right here, it would show what that FFT would look like. One thing to keep in mind though is that if you import this into DT6 after you hit the stop button here, the FFT and the waveform won't necessarily look exactly the same as they do here, just because the DT6 analysis software does a lot more analysis and trimming and cleaning up the signal than it does here. So these are a little bit more raw. The gravity portion hasn't necessarily been taken away. The FFT will look a little bit cleaner on the other one. But those are just things to keep in mind. So right now, you can see this is going to be cutting the blue sensor. So basically, if we were to cut it here, and we'll hit the stop button to cut it, then it would pop up with the green sensor, and by default it would show us this location and this location, so that you could cut it in the same spot if you wanted. But if for some reason you wanted one sensor to be like shifted over or something, or not necessarily cut in the same region, you can move it accordingly. So I'm going to go ahead and say that I don't need exactly 60 seconds. I'll go ahead and do like 55, which should give us about 30 seconds. So I'll go ahead and cut it here for A. And then it comes up with this dialog that says, are you sure you want to cut the waveform at this spot? So if you hit yes, it'll go forward, and if you hit no, it'll let you continue. So I'm going to hit no first just to show you that. So then it just brings back up here as if nothing had happened. But I'm going to go ahead and actually cut it here. So we'll hit yes. Then it'll pop up with the green one. You can see here now the backboard has been colored green instead of blue. And by default, it shows us the cursor locations that we cut blue at. So if we want to cut the green one at the same location that blue was cut, this is where those cursors were on the previous screen. But if, for instance, you had the sensors on two different motors, or the inboard and the outboard, the portions of the waveform that you might want might not necessarily be the same for both. So you could cut green accordingly. But I'm going to go ahead and say that they're on the same inboard, so I'm going to go ahead and cut it as it is. So we'll hit stop, and we'll say, are you sure you want to cut it at the spot? We'll hit yes. And then you can wait a few seconds, and you'll see these lights turn green. And that means that you have data now. So just like when you hit acquire and you run it for a certain amount of time, and then you get data, and then these guys turn green. The live mode will do the exact same feature. Once it's done processing that data,